The sweltering heat shimmered across Tachikawa Airfield in the summer of 1943 as Lieutenant Funebashi settled into the cockpit of the second K84 prototype. His gloved fingers moved across the throttle quadrant with the care of a craftsman handling something precious. Below, Chief Engineer Koyama stood with a stopwatch clutched in his weathered hand, his face etched with the intensity of someone who had devoted 18 months of grueling 16-hour days to this singular moment. This was the day Japan would prove it could build a fighter to rival America's renowned P51 Mustang. The Nakajima HAO-45 Homar engine roared to life beneath Funebashi's hands, its 18 cylinders promising 2,000 horsepower, more raw power than any Japanese fighter had ever delivered. As he advanced the throttle, the aircraft strained against its brakes like a trapped animal straining for freedom. The sound was magnificent, a deep mechanical growl that spoke of speed and overwhelming force in equal measure. The prototype lifted off with commanding authority, its nose climbing toward the blue sky with startling aggression. The climb rate immediately exceeded every expectation. Funebashi watched his instruments as the Hayate, the name meaning gale or storm, clawed skyward at 2,780 feet per minute. Below him, Koyama's engineering team scattered across the tarmac, some shouting observations to stenographers while others simply stared upward in amazement. This was the kind of climb rate that could match anything the Americans possessed. At 15,000 feet, Funebashi leveled off and began his speed runs. The airspeed indicator crept steadily upward, past 350 miles per hour, then 360, then 370. His heart hammered in his chest as the needle approached 380. When it touched 387 miles per hour, he eased back slightly on the throttle and keyed his radio. Maximum level airspeed achieved, 387 miles per hour, he reported, his voice steady despite the excitement coursing through him. Inside the engineering hangar, those words reached Koyama's ears and seemed to dissolve 2 decades of professional struggle into pure elation. 387 miles per hour. Yes, the American P51D model achieved 437 miles per hour in optimal conditions, but that 50-mile gap suddenly seemed entirely bridgeable, especially when one considered the K84's vastly superior firepower. The devastating 20mm cannons paired with 212mm machine guns against the Mustang's 650 caliber guns. Those cannons would prove decisive against B-29 bombers and heavy American formations. The K84 represented a fundamental shift in Japanese fighter design philosophy. The legendary Zero had dominated the Pacific's early battles through speed and maneuverability, but American pilots had learned to exploit its fatal weakness: the complete absence of pilot protection. The K84 featured 13mm of head and back armor, multiple structural bulkheads reinforcing the fuselage, and that impressive 65mm armor glass canopy. Japanese pilots would no longer become casualties of single lucky shots. As Funebashi entered his landing approach, the aircraft's advanced features revealed themselves in subtle ways. The direct fuel injection system delivered smooth, consistent power throughout every phase of flight. The hydraulic systems responded with mechanical precision to his control inputs. Even the landing gear, a complex assembly that had troubled earlier prototypes, extended and retracted flawlessly. When the main wheels touched down on Tachikawa's runway, Funebashi felt the reassuring bite of effective wheel brakes, the kind of detail that separated genuinely professional aircraft from experimental curiosities. Ground crews immediately swarmed the prototype as Funebashi shut down the engine. Mechanics began their systematic checks: engine temperatures, oil pressure readings, fuel consumption figures. Their preliminary assessments proved extraordinary. The HAO-45 had run cool throughout the entire flight, consuming fuel at rates that promised impressive operational range. More importantly, the post-flight inspection revealed nothing troubling. No mechanical anomalies, no stress fractures, no warning signs of impending failure. In the debriefing room, Funebashi faced a semicircle of engineers, military officials, and production managers, all listening intently to his every word. His report was methodical and precise, yet devastating in its implications for American air superiority. Control response remained immediate and precise throughout the speed range. Engine performance delivered consistent power delivery from sea level to 20,000 feet. All 4 weapon systems fired without malfunction during test bursts. Conclusion: this aircraft meets or exceeds all performance specifications. Factory manager Yamamoto, representing Nakajima's production division, studied the test data with barely concealed excitement. The Imperial Japanese Army Air Force had already placed preliminary orders for over 3,000 Ki-84 fighters, and these results would certainly trigger additional contracts. His mind was already calculating production schedules, material requirements, and delivery timelines. The war had created unlimited demand for high-performance fighters, and Japan finally possessed a design worthy of mass production. Yet even in this moment of triumph, subtle warning signs flickered at the edges of awareness. The HAU-45 engine, for all its impressive power, ran hotter than previous Japanese radials. Ground crews noted that post-flight engine temperatures remained elevated far longer than expected, suggesting potential cooling system limitations that might prove problematic in tropical combat zones. The complex direct injection system, while delivering superior performance, demanded far more precise maintenance than the simple carburetors powering most Japanese aircraft. Most troubling was the landing gear assembly itself. While it had functioned perfectly during testing, the mechanism was significantly heavier and more complex than previous designs. Those precision-machined struts and integrated brake systems represented manufacturing challenges that would severely stress Japan's industrial capacity as production scaled upward. Koyama's perfectionist engineering had created something genuinely remarkable, but masterpieces demanded master craftsmen to produce them. As summer faded into autumn of 1943, the K84 program accelerated toward full production. Test pilots throughout Japan reported consistently impressive results. The fighter outperformed every existing Japanese design while approaching Mustang-level capabilities. Intelligence reports from the Pacific suggested that American pilots, grown dangerously confident through months of aerial dominance, remained unprepared for a Japanese fighter that could match their speed and exceed their firepower. The promise seemed absolute. Japan had built a plane to beat the P51 Mustang. The prototypes had proven it. The test data confirmed it. The production orders reflected it. But promises made in engineering laboratories would soon face the brutal realities of wartime manufacturing. The Hayate's true test would come not in the controlled environment of Tachikawa Airfield, but in the chaos of mass production under an increasingly desperate empire. Squadron leader Kobayashi adjusted his parachute straps as he walked across the dusty airfield outside Hankow, China, in August of 1944. The oppressive heat pressed down like a physical weight. The 22nd Sentai had received their first operational Hayates just 2 weeks earlier, and today would mark their combat debut against American Army Air Force fighters that had grown dangerously confident over Chinese skies. The morning briefing had been electric with anticipation. Finally, Japanese pilots would fly aircraft that could match the enemy's vaunted Mustangs and Thunderbolts. The first combat sorties exceeded every expectation. American pilots, accustomed to easily outrunning Japanese interceptors, found themselves facing fighters that could not only match their speed, but deliver devastating cannon fire from impossible angles. Lieutenant Sasaki's after-action report captured the American shock perfectly. Enemy formation scattered immediately upon visual contact. 2 P-51s attempted high-speed disengage, unsuccessful. Both destroyed by 20mm cannon fire at 400 miles per hour, indicated airspeed. For 3 weeks, the 22nd Sentai's K84s terrorized American formations over central China. The psychological impact was immediate and profound. American bomber crews who had grown accustomed to Japanese fighters falling behind during escape runs now faced interceptors that could pursue them at maximum speed while delivering accurate fire. The tactical balance that had favored American aviation seemed to shift overnight, but Kobayashi began noticing troubling patterns emerging from successful missions. Aircraft War Team 46 returned from a routine patrol with hydraulic fluid streaming from its landing gear assembly. The pilot reported normal flight characteristics, but post-flight inspection revealed stress fractures in the main gear struts, fractures that hadn't existed during pre-flight checks. Maintenance Chief Watanabe examined the damaged components with growing concern, noting that the steel appeared brittle, almost crystalline in its structure. 3 days later, aircraft 1952 suffered complete landing gear collapse during touchdown. Pilot Officer Tanaka walked away uninjured, but the K84 was a total loss. Its fuselage twisted beyond repair, engine mounts cracked, propeller blades bent into useless twisted sculptures. The accident report listed mechanical failure as the cause, but Kobayashi's experienced eye detected something far more sinister. The quality of materials was inconsistent with the prototypes they had tested back in Japan. A detailed inspection of the collapsed gear revealed the scope of the problem. The heat treatment of the steel struts was uneven, creating areas of extreme hardness adjacent to sections that remained dangerously soft. Under the stresses of combat maneuvering and heavy landings, these inconsistencies acted like fault lines, spreading fractures through critical load-bearing components. This is not the same steel quality we saw in the early production aircraft, one experienced mechanic reported to Kobayashi. Something has changed in the manufacturing process. The engine problems proved even more concerning. The HAU-45 Homar that had performed flawlessly in prototypes now exhibited wild power variations from aircraft to aircraft. Lieutenant Yamada's fighter produced barely 1,800 horsepower at takeoff, while Sergeant Okada's identical aircraft delivered the promised 2,000. The engines fell significantly short of their promised output, delivering roughly 200 horsepower less than the specifications required. Sergeant Pilot Edo's power plant ran with such intense heat that he was forced to scrub 2 separate missions when the cylinder heads threatened to exceed safe temperatures. The situation turned truly alarming when Pilot Officer Fujita experienced a complete engine seizure at 8,000 feet while deep in hostile territory. His exceptional piloting ability and sheer fortune proved to be his only lifelines. He managed to nurse the dying aircraft back across friendly lines and execute a landing without any engine power whatsoever. The investigation that followed revealed something profoundly troubling. These engines were supposed to be identical, built to exact specifications, yet the actual horsepower varied by as much as 200 from one unit to the next. Some of the Homar engines produced smooth, reliable power across every flight regime. Others ran roughly, overheated constantly, or experienced unexpected component breakdowns. The meticulous manufacturing precision that had made the prototype perform so spectacularly was vanishing from the production line with alarming speed. By September, the 22nd Sentai's operational readiness had declined from 80% down to just 65%. Fighters that should have commanded the Chinese skies sat idle instead, waiting for replacement parts that trickled in sporadically or failed to arrive altogether. Kobayashi found himself making agonizing choices about which pilots could fly on any particular day, forced to select only from the handful of aircraft that remained mechanically dependable. The toll on pilot morale was catastrophic. These airmen had invested enormous effort preparing for combat, studying performance data they'd memorized, drilling tactics designed to exploit the Hayate's speed advantages, and mentally preparing themselves for battles in a fighter that could compete with American machines. What they encountered instead was vastly different. Their aircraft might fail without any warning, possibly mid-flight. Pilot Officer Nakamura recorded his deepening frustration in his personal diary entries. During a combat engagement against P-40 Warhawks, his engine suddenly lost power. Aircraft he should have outpaced effortlessly nearly destroyed him because his Homar couldn't hold full power above 12,000 feet. He wrote that American pilots weren't superior, simply that their machines actually performed as promised. Similar troubles surfaced across other K84 squadrons. The 52nd Sentai in the Philippines experienced recurring landing gear collapses. The 73rd Sentai operating from Formosa documented matching engine inconsistencies. Factory manager Yamamoto faced an avalanche of demands for technical support, spare parts, and answers regarding the deteriorating quality of aircraft leaving his facilities. Intelligence reports sourced from captured American pilots painted a disturbing picture. One downed P51 pilot described his briefings about encountering new Japanese fighters with better performance, but admitted that roughly half of them displayed obvious mechanical problems. Some struggled merely to keep pace with American bombers, much less engage their fighter escorts. The numbers were impossible to deny. Enemy gunfire remained within manageable limits for experienced pilots flying the K84. The aircraft's armament and protection allowed them to engage American fighters relatively evenly. But mechanical failures were stripping nearly 30% of the aircraft from service without firing a single shot in anger. Collapsing landing gear, engine breakdowns, hydraulic system failures, and brake malfunctions were removing fighters from the fight more effectively than American ammunition. Kobayashi's October status report to headquarters told a devastating story. From an original complement of 18 aircraft, only 9 remained operational. 3 losses came from enemy action. 6 had been lost to mechanical failures. He requested immediate technical support and urgent delivery of replacement aircraft built to the original specifications. Tokyo's reply was simultaneously enlightening and horrifying. Replacement aircraft were being manufactured at maximum capacity. They had reduced quality control standards to meet the urgent production demands. Japan's perfect fighter, designed specifically to defeat the P51 Mustang, wasn't being destroyed by enemy pilots, but by the industrial desperation required to build it quickly enough for a war already slipping away. On November 24, 1944, the first B-29 super fortresses appeared above Tokyo Bay. Their polished aluminum fuselages gleamed menacingly at 30,000 feet. From his window at the Nakajima factory in Ota, Chief Engineer Koyama observed the formation passing overhead and felt absolute certainty wash through him. His entire world was about to transform completely. These bombers moved unchallenged through skies too high for most Japanese interceptors. Their appearance signaled that American industrial power had finally penetrated Japan's homeland. 3 days later, factory manager Yamamoto received accelerated production orders. The K84 output needed to jump from 40 aircraft monthly to 120 by January 1945. The directive arrived without additional resources, no extra steel, no supplementary workforce. Only a demand that the impossible become reality through willpower and sacrifice. Yamamoto studied the new production schedule spread across his desk and calculated what his career experience already confirmed. Quality would inevitably become the first victim of this accelerated timeline. The initial Super Fortress raids struck aircraft factories with remarkable precision. On February 10, 1945, waves of B-29s descended on the Ota complex in broad daylight. They released countless 500-pound bombs across Nakajima's production buildings. The blasts demolished assembly operations, obliterated specialized machinery, and buried stockpiled components beneath mountains of wreckage. Koyama witnessed 17 years of engineering achievement disappear during just 90 minutes of systematic destruction. 14 days afterward, carrier aircraft from Task Force 58 attacked what remained. A coordinated assault that displayed America's staggering air superiority. Hellcats and Corsairs swooped low overhead. Their 50-caliber machine guns sprayed destruction across anything resembling industrial capability. The strikes became so relentless and devastating that ordinary manufacturing proved impossible. Nakajima adopted a dispersal program scattering K84 production across numerous smaller workshops concealed within schools, religious buildings, and fortified tunnels. This fragmented approach reduced output to less than a quarter of what was needed, while simultaneously dismantling the already fragile quality control procedures. Components manufactured inside a repurposed schoolhouse in Gunma produced measurements wildly inconsistent with requirements. Engine parts assembled in underground caverns lacked the precise machining essential for proper HOMAR function. Most problematically, the heat treatment machinery crucial for correct steel processing was too substantial and detectable to conceal from American aerial observation. Yamamoto's daily production records chronicled a systematic disintegration of manufacturing capacity. Supplies of quality steel vanished, as bombing campaigns crippled transportation routes and demolished specialized mills. The sophisticated alloys needed for landing gear supports were substituted with whatever metals could be salvaged from destroyed structures and abandoned wreckage. Quality inspectors, numerous of whom had been conscripted into combat roles, were replaced by older volunteers lacking proper technical credentials to catch defective parts. Fuel shortages magnified every other difficulty exponentially. The Homar had been engineered for high-octane aviation fuel, delivering smooth, steady combustion throughout its 18-cylinder design. By early 1945, Japanese refineries could only manufacture low-grade synthetic substitutes, causing the complicated engine to run harshly, overheat, and fail prematurely. Hastily modified carburetor versions meant to ease maintenance proved even worse than original fuel injection when forced to operate on inferior fuel. Lieutenant Funebashi trained replacement aviators on machines he scarcely recognized from his test flights a year and a half prior. The original K84 prototypes had achieved 387 miles hourly under ideal conditions. Factory-delivered versions barely exceeded 250. Engine performance fluctuated so unpredictably that pilots couldn't reliably estimate their aircraft's capabilities between flights. Aircraft accident reports landing on Funebashi's desk revealed the human consequences of industrial breakdown. Pilot Officer Sato perished when landing gear collapsed without warning during routine training, the structural supports fracturing due to deficient heat treatment. Lieutenant Yoshida survived his forced landing from complete engine failure, though the aircraft was demolished when inadequate brakes couldn't decelerate the powerless machine before it struck a drainage channel. Flight Sergeant Kimura's death proved most tragic, dying in a crash resulting from control surface deterioration. A structural failure investigation traced to substandard fasteners manufactured from scrap material in an improvised workshop. Manufacturing records documented an industrial apparatus in its final stages of failure. Original K84 specifications projected 3,000 aircraft by war's conclusion. Spring 1945 showed fewer than 2,800 completed, with operational readiness for existing aircraft falling below 45%. American intelligence estimates believed Japanese production was actually increasing, failing to account for quality degradation that rendered new aircraft essentially combat useless. A submarine blockade surrounding Japanese territory prevented arrival of vital components unavailable through domestic manufacturing. Precision instruments, specialized bearings, and superior-grade materials all demanded resources or production methods Japan no longer controlled. K84 machines departed assembly lines missing crucial components or installed with makeshift alternatives that endangered their own operators. Squadron leader Kobayashi, temporarily reassigned to develop replacement pilots at Kasumi-Gara Air Base, observed waves of fresh aviators confronting aircraft bearing minimal resemblance to the machines they'd trained for. Young men devoting months to mastering K84 characteristics flew machines responding unpredictably, failing mechanically without notice, and struggling merely to pace American bombers they were meant to intercept. Hidden factory complexes represented Japan's ultimate desperate push to continue aircraft manufacturing. Sophisticated tunnel networks excavated into mountainsides housed production lines engineered to manufacture 204 fighters monthly while remaining undetectable through American reconnaissance. But underground workshops suffered from inadequate ventilation for painting operations, insufficient illumination for precise assembly, and poor logistics for moving finished machines to combat bases. Most critically, they reproduced none of the quality oversight that had distinguished original prototypes. By April 1945, the separation between engineering design and manufacturing reality had become insurmountable. This same machine promising to re-establish Japanese air dominance had transformed into something more hazardous to its own pilots than to adversaries. Yamamoto's production documentation revealed an industrial catastrophe unfolding. Japan retained the technical expertise required for manufacturing excellent fighters, but had surrendered the production capability to construct them dependably. The confluence of relentless bombing, scarce materials, and desperate output goals had converted the K84 from Japan's crowning aviation accomplishment into a monument to manufacturing failure. The Okinawa offensive commenced at sunrise on April 1, 1945, and shortly thereafter, the grim truth of Japan's circumstances became undeniable. American forces had established positions merely 350 miles from Kyushu, sufficiently close that their escorts could protect bombers striking any target throughout the Japanese homeland. Squadron leader Kobayashi received that afternoon's orders, directing him to ready 11 K84 machines for a final suicide assault against American airbases being constructed from Okinawan terrain, requiring his fighters to operate perfectly across the longest ocean crossing most of his pilots would undertake. The pre-flight examinations disclosed the comprehensive manufacturing emergency that had consumed Japanese aviation. The hydraulic lines on aircraft 1463 were weeping fluid from every major connection point. The cause traced back to rubber compounds used in seals, materials so brittle and inferior that they simply couldn't hold pressure when the fighter pushed hard during combat maneuvers. Over on aircraft 1471, the port landing gear refused to cooperate during ground tests, extending only part way before jamming stubbornly. The actuator mechanism had bound up completely, a direct result of sloppy machine work on the hydraulic cylinders. Tolerances so loose they might as well have been guesswork. But aircraft 1458 presented the most troubling sight of all. When maintenance crews ran its Homar engine, thick black smoke rolled from the exhaust. Internal damage, unmistakable and severe. The parts needed to fix it simply didn't exist anymore. Maintenance Chief Watanabe faced an impossible situation. Out of 18 fighters theoretically assigned to his squadron, he needed to somehow create 11 that could actually fly. He worked straight through the night, his repair efforts resembling field surgery more than careful technical work. There was no other choice. He cannibalized parts from the broken machines to keep others running. Fuel pumps came out of aircraft 1444 and went into aircraft 1467. Landing gear struts from aircraft 1455 replaced the cracked assemblies in aircraft 1473. By April 14th, Watanabe had accomplished his grim miracle. 11 fighters assembled from the wreckage of 18 broken machines. The briefing on April 15th laid bare just how impossible the situation really was. Intelligence reports showed American forces had established 3 operational airfields on Okinawa, defended by more than 200 fighter aircraft. Among them were the latest P51 Mustangs and P47 Thunderbolts, machines that outclassed anything the Japanese could throw at them. Kobayashi's 11 K84 fighters would have to fly low to slip past radar, climb to bombing altitude over the target, strike the parked aircraft and fuel dumps, then fight their way back through overwhelming fighter opposition to reach Kyushu. At 0530 hours, the formation launched. Kobayashi led them in aircraft 1469, one of the precious few that still performed anywhere near its original specifications. For the first hour, everything proceeded smoothly. 11 fighters held tight formation, skimming just 50 feet above the wave tops to avoid detection. Then, the mechanical demons that had haunted K84 operations all through 1945 began to emerge. At 06:45 hours, aircraft 1472, flown by pilot officer Sasaki, started trailing white smoke. Its engine was consuming oil at a terrifying rate. The Homar's cylinder head temperatures climbed steadily into the red warning zone. Despite Sasaki's efforts to throttle back and lean out the fuel mixture, 20 minutes later, the engine seized completely. The internal components welded themselves together from heat and starvation of oil. Sasaki had no choice but to attempt a water landing, the first casualty of a mission that hadn't yet encountered a single enemy fighter. The formation continued toward Okinawa with 10 aircraft now, but new problems kept surfacing. Lieutenant Tanaka reported that hydraulic pressure was fluctuating in aircraft 1468, making the flight controls increasingly sluggish and unresponsive. The fuel flow gauge in aircraft 1471 bounced around wildly, suggesting pump trouble or contaminated fuel lines that might starve the engine without warning. Most ominously, aircraft 1465 began losing electrical power. Radio communication died first, then navigation instruments faded away. And finally, the engine monitoring systems went dark. As the remaining formation approached Okinawa's coast at 07:15 hours, American radar operators spotted the low-flying Japanese fighters. They vectored interceptors to intercept before the Japanese could reach their targets. P51 Mustangs dove from above, trying to bounce the Japanese fighters before they could climb to bombing altitude. Kobayashi ordered maximum power and began climbing, but several of his machines couldn't respond. Aircraft 1464, flown by Flight Sergeant Watanabe, suffered complete engine failure during the climb when its connecting rod snapped and punched straight through the crankcase. The catastrophic damage turned the engine into pure drag. Watanabe had no option except to attempt a dead stick landing on the contested island below. Aircraft 1467 experienced an unexpected landing gear extension right in the middle of combat climb, a hydraulic failure that created so much drag the fighter couldn't maintain formation speed. The actual attack became a chaotic running battle where mechanical failures did more damage to the Japanese effort than enemy gunfire. Lieutenant Yoshida managed to drop his bombs on a fuel dump, but his 20mm cannons jammed as soon as he tried his strafing run. The ammunition feed mechanisms were faulty, clogged with debris. Pilot Officer Nakamura lost all hydraulic pressure during his bombing run, leaving the controls so heavy he could barely hold level flight, much less perform combat maneuvers. The withdrawal from Okinawa turned into a desperate race. American fighters pursued relentlessly. Aircraft 1473 suffered complete brake failure during escape, the wheels locking and creating drag that made it an easy target for pursuing Mustangs. The total electrical failure in aircraft 1465 forced the pilot to navigate by dead reckoning, while multiple enemy fighters attacked from all sides. Of the 11 Ki-84 fighters that launched that morning, only 3 returned to base. 2 of those suffered landing gear collapses during touchdown because the steel used in the struts was brittle and inadequately heat-treated, standard for late war production. The mission accomplished virtually nothing. American airfields sustained minimal damage, repaired within hours. But the strategic implications were devastating. Japan's most advanced fighter had proven unable to even conduct basic combat operations. Kobayashi's after-action report documented the complete disintegration of Japanese aviation capability. Mission effectiveness reduced to 0 due to mechanical failures exceeding combat losses by a ratio of 2-to-1. Aircraft that reached the target area could not maintain formation or execute coordinated attacks because individual systems were failing constantly. His recommendation was stark: suspend all Ki-84 combat operations until manufacturing quality control could be restored to acceptable standards. A pilot diary entry discovered in aircraft 1469 after the mission captured the human weight of industrial collapse. Today I flew what was supposed to be Japan's best fighter. The engine coughed at 15,000 feet. The landing gear warning light flickered constantly throughout the flight. When I landed, the left strut folded immediately. This is not the plane that was promised to us in training. This is not the weapon that will save Japan. The atomic bomb that destroyed Hiroshima on August 6, 1945, vaporized not just a city, but also the final illusions of Japanese resistance. Underground, carved deep into mountainsides around Nagoya, factory workers continued assembling Ki-84 fighters using components so substandard that finished aircraft could barely taxi, much less conduct combat missions. Factory manager Yamamoto walked through tunnels lined with partially completed fuselages whose engines would never start, whose landing gear would collapse on contact with the ground, whose control surfaces had been fabricated from materials salvaged from destroyed buildings. The plan to produce 200 aircraft monthly had become a cruel fantasy. These underground assembly lines turned out perhaps 30 fighters each month, and half of those were immediately grounded because of mechanical failures discovered during engine run-ups. The precision tooling necessary for the Homar engines had been destroyed in bombing raids months earlier, replaced by improvised equipment incapable of maintaining the tight tolerances required for reliable operation. Workers who once crafted components accurate to thousandths of an inch now struggled to achieve precision measured in fractions of an inch. Chief Engineer Nakajima received test reports documenting the complete collapse of Ki-84 performance. Late production aircraft, theoretically identical to the prototypes from 1943, now achieved maximum speeds below 250 miles per hour, slower than the American P-40 Warhawk that had been obsolete since 1942. The Homar engines produced power so inconsistent that pilots couldn't predict whether their aircraft would climb normally or barely maintain altitude in level flight. Lieutenant Funebashi conducted acceptance flights on fighters that bore only surface resemblance to the machines he had tested 2 years earlier. The cockpit instruments were crude substitutes for the precision gauges originally specified, often producing readings so inaccurate that pilots flew by intuition rather than data. Hydraulic systems leaked constantly, pooling fluid on hangar floors and creating slippery conditions that made ground operations hazardous. The armament systems that might have made the Ki-84 superior to American fighters now jammed regularly because ammunition was manufactured in makeshift factories from inferior materials. Fuel became catastrophically scarce as Japan's synthetic refineries suffered repeated bombing attacks. The high-octane aviation gasoline that allowed the Homar engine to produce its rated 2,000 horsepower was replaced by crude substitutes that caused severe engine knock, overheating, and premature component failure. Pilots reported their engines losing power unpredictably during flight, sometimes recovering after several minutes, but often forcing emergency landings that usually resulted in landing gear collapse because the brittle steel used in late war struts couldn't absorb the impact. Squadron leader Kobayashi, now assigned to defend the Tokyo area with whatever aircraft could be made airworthy, faced the impossible task of intercepting B-29 bombers with fighters that could barely reach the altitudes where superfortresses operated. His pilots, many of them teenagers with less than 50 hours of flight training, struggled to control aircraft whose flight characteristics changed from day to day, depending on which components had been replaced with substandard substitutes during maintenance. By July 1945, the mechanical failure rate reached catastrophic levels. Over 50% of Ki-84 fighters were grounded at any given time, waiting for parts that would never arrive or repairs that couldn't be completed with available materials. Aircraft that managed to take off faced a 20% probability of suffering critical system failures during flight. These failures often proved fatal to pilots lacking experience to handle emergencies in machines whose backup systems had also been compromised by poor manufacturing quality. When American technical personnel arrived in Japan following the surrender, they revealed the full extent of the engineering tragedy that had engulfed the Ki-84 program. Captain Chuck Morrison, a test pilot assigned to evaluate captured Japanese aircraft, approached his examination with the methodical professionalism that characterized American technical intelligence. His initial visual inspection noted numerous manufacturing defects that would have been rejected immediately in any American factory. Morrison's flight test of the captured Ki-84, using high-octane American aviation fuel, produced results that stunned both American and Japanese observers. With proper fuel and basic maintenance to correct the most obvious problems, the fighter achieved a maximum speed of 426 miles per hour, just 11 miles per hour slower than the P51 Mustang's top speed. Climb rate improved dramatically to over 3,000 feet per minute. Most remarkably, all systems functioned exactly as originally designed when provided with quality components and proper maintenance procedures. The post-war revelation carried devastating implications. Japan had indeed designed a fighter capable of matching or exceeding American aircraft performance. The Ki-84's engineering was fundamentally sound, its aerodynamics were efficient, and its power plant was potentially superior to anything America produced when properly manufactured and maintained. The failure wasn't conceptual, it was industrial. Japan's manufacturing capacity had collapsed under total war, making it impossible to build the aircraft their engineers had designed. Funebashi watched Morrison's test flights with emotions mixing professional admiration with profound grief. The American pilot flew the Ki-84 exactly as Funebashi had flown the prototypes in 1943. Smooth power delivery, responsive controls, performance that justified the optimism that had once surrounded the program. "We had the right design," Funebashi reflected as he watched Morrison demonstrate the fighter's capabilities. We just couldn't build it when it mattered most. American technical analysis revealed the scope of the industrial catastrophe. Of 3,514 Ki-84 fighters produced during the war, fewer than 1 in 200 achieved acceptable operational status at any given time. Combat losses to mechanical failure exceeded combat losses to enemy action by nearly 2 to 1. The aircraft that should have restored Japanese air superiority instead became a symbol of industrial collapse under the pressures of total war. Factory manager Yamamoto, interviewed by American investigators, provided insight into the cascading failures that destroyed Ki-84 production quality. The bombing of precision tooling facilities, the loss of skilled workers to military units, the substitution of inferior materials, and the impossible production quotas combined to create a perfect storm of manufacturing problems. We knew we were building defective aircraft, he admitted, but the alternative was building no aircraft at all. The single Ki-84 that survived the war intact became a monument to engineering excellence destroyed by industrial limitations. Displayed at the Tokugawa Aerospace Museum in Chino, the preserved fighter represents both the pinnacle of Japanese aviation design and the tragic consequences of attempting to mass-produce precision aircraft under impossible wartime conditions. Museum visitors, unaware of the fighter's complex history, see only a sleek aircraft that appears capable of challenging any fighter of its era, which under the right circumstances it absolutely was. The Ki-84 story became the definitive case study of the difference between engineering brilliance and manufacturing capability. Japan's engineers had created a fighter that could beat the P51 Mustang. Their industrial system, crushed under the weight of total war, proved incapable of building that fighter when the nation needed it most.